Today we're talking about implicit differentiation. You use implicit differentiation when you're taking the derivative of an equation with multiple variables. This allows you to relate one variable to another and solve the equation. I'm going to show you this with an example. So this is our example problem, 2x squared plus y squared equals 7. The first step that we're going to take is to take the derivative with respect to x of this equation. We'll start with the things that we know how to take the derivative of. For example, 2x squared and 7. We know that 7 is going to be 0 because it stays constant. And we also know that the derivative of 2x squared is going to be 4x. Now, the problem is we have y squared. We can't just simply take the derivative with respect to x of y. We have to relate the two variables. So the first thing you do is take the derivative with respect to y, which is going to be 2y, and you multiply that by the derivative of y with respect to the derivative of x. And then from there, you can just solve the equation. And it also makes sense because that's what you're solving for. That's what you're trying to find is the derivative of the equation, dy over dx. So the first thing you do is subtract 4x from both sides. And then divide by 2y. And then simplify. And then there's your answer.
Alright guys, we're back here with implicit differentiation, this time with the example problem 6x squared minus 8xy plus y squared equals 54. To start this problem, we're going to take the derivative. So, d dx of the quantity 12x minus, and notice here there's a product rule being first times the derivative of the second plus second times the derivative of the first. So to solve this, we have 12x, and then we have in a different quantity, plus negative 8x dy dx. The dy dx coming from this, the derivative of y, which has no correlation to x yet. So when putting in dy dx, it then has a relation to x. So then from there we have plus the quantity negative 8y plus 2y dy over dx. dy over dx again coming from the derivative of this. And all of this equals 0, 0 being the constant of the derivative of 54. So from here, the next step is to factor all this. And we factor all this by taking out the common term dy dx in both these locations with the negative 8x and the 2y. So from here, we have dy over dx times the quantity of negative 8x plus 2y. And then from here, we just have what's left over. So we've got 12x, and we have the 8y, negative 8y. So then we have plus 12x and minus 8y. All of this equals 0. So from here, we're just going to solve for dy dx. And we do that first by moving the 12x and the negative 8y over to the right side. So dy over dx of negative 8x plus 2y equals negative 12x and then plus 8y. From here, we're going to move the negative 8x plus 2y over to the right side by division. So dy over dx equals negative 12x plus 8y all over negative 8x plus 2y. The final step in this is simply to simplify. And we do that by taking 2 out of everything. So we're left with dy over dx equals negative 6x plus 4y over negative 4x plus y. And there's your answer.